Hello and welcome to this video. So we are starting a series on solving 100 integration questions. So the first question we have in our series is the integral of this function that has been defined. We have 1 upon root x into bracket 1 plus x dx. We have to solve this question and get an answer. So how do we go about solving those questions? So the first thing we are going to do is determine the method that we are going to use to solve this integration. So we see, of course, that we cannot make use of integration by part because I do not need to make use of that. We can as well not make use of integration by partial fraction. So because we don't want to go about that route, right? So and we will check if we can actually make use of integration by substitution. In fact, that is one of the assumed way of solving integration firsthand. So if that fails, then you can go ahead to look at these several other options based on the rules governing them. All right, so we have this question and we are using integration by substitution to solve this. So we have u now to be equals to the square root of x. So we are assuming that u is actually equals to the square root of x. So if I differentiate u, that is, I want to find du dx. If I differentiate u with respect to x now, I'm going to get 1 over 2 root x. So this is something that we can do. And of course, this implies I can easily say that du now is actually equals to 1 over 2 root x dx. So du is equals to this. So we can go ahead and say, if we look at this, we know that u equals to square root of x. If I take the square of both sides, it's going to imply that u squared is actually equals to x by taking the square of both sides. So if we go back and substitute everything we have into the function upon which we have our integral, we are going to be having integral of 1 over square root of x is u. So u into, so this will be 1 plus, now x is u squared, so 1 plus u squared dot, now dx, right? From here, dx now, what do we think dx is going to be? So to get the value of dx now, we know that we want to get the value of dx. So that means this amazing guy from here, dx can be equal to du, right? Can be equals to, rather, 2 root x du by cross multiplying. So this is 2 root x du. But we know that root x is actually equals to u. So this is just like saying dx equals to 2u du. So I'm going to put 2u du. So from here, this u is going to cancel this u, and I'm going to have integral of 1 over 1 plus u squared multiplied by 2 du. Now, 2 is a constant, which means I can actually bring that out of my integration. So this will be 2 integral of 1 over 1 plus u squared du. So now, interesting. What can we do? So right there is a theorem that we can actually apply in this case. If you recall, we know that the integral of 1 over a squared plus x squared dx can be equals to 1 over a arctan of x over a plus c. So if you look at this, you see that this is similar. So I can say this is integral of 1 over 1 plus u squared du. I can write this as 2 integral of 1 over 1 squared plus u squared du. So if you look at this and what we have up here, we'll see that they are almost the same. So right, of course, a now will be 1 and our x will be u. So this can be 2, which is the number we have outside, into 1 over 1 arctan, then x is now u, that is u over 1. So from this, we know that this can be 2, 1 over 1 is 1, and u over 1 is u. So that will be 2 arctan of u. But we know that u is actually the square root of x. So since u is actually the square root of x, we can now say that definitely our integral, the integral now of x root x into 1 plus x dx will be equal to arctan. Don't forget that we have these two, right? So that will be 2 arctan u plus c. Now, since we know this, then this can now be 2 arctan. So we are going to replace the u with what we have originally, since we are working with x. So u is actually equals to the square root of x. So this will be equals to 2 arctan of root x plus c. And that is the solution to this integration problem. I hope you've learned something in this video, and I hope you stick around to watch the next one. I hope to see you. Thank you. And do not forget to subscribe, follow this channel. Do enjoy your day. Bye.